And our next speaker is Laurent Simon, is a security engineer in the Google open source security team. He works on tooling for software development lifecycle and supply chain integrity, and will be talking to us about assessing and improving the security practices of open source projects. So without further ado, let's bring Laurent on. Hey there, how you doing?
Hi, I'm doing well. How about you guys?
Doing well, doing well. Thank
Very
you.
well.
I'm excited to hear about what you have to share with us. So Eric and I are going to jump off and let you take it away.
Okay, cool. Thanks. All right. Hi, everyone. So yeah, thanks for the intro. I'm Laurent. I'm a security engineer at Google, and today I'll be talking about a project called Scorecard, which can help you assess and improve the security of open source projects. So I work at Google as a security engineer. I spend a lot of my time working with the OpenSSF on two of their main projects, the Scorecard project, which is the topic of this talk, and the Allstar project, which is a framework that helps secure your release pipeline. So I'm not sure everyone knows about the OpenSSF, so let me say a few words about it. The OpenSSF is the Open Source Security Foundation. It's an organization where multiple companies collaborate to help improve the security of open source software. We do this by writing tools such as Scorecard. We provide consulting, perform code audits, and sometimes also publish best practice documents. Everything in the OpenSSF is open. So we have public working groups, Slack channels, bi-weekly meetings that are open for everyone to join. If you're interested, take a look at the openssf.org and join the conversation. All right, so as most of you may know, most of the third-party dependencies in modern software come from open source, around 90% of them, and several critical pieces of software we use every day in production, such as Kubernetes or OpenSSL, come from open source. However, supply chain attacks are on the rise, and attackers are realizing that it's much easier to attack the supply chain than it is to find bugs in the actual software. And over the past 2 years, we've seen significant rise in these attacks, as illustrated in this slide here. In this slide, we have tried to visualize the various components of the supply chain. And as you can see, there are quite a lot of places where an attacker could try to target your project. Starting by just sending malicious pull requests to exploit an overprivileged CI run where you run your tests, for example. And I'll show a demo of this later in this talk. An attacker could also compromise your software source control system, which happened in the PHP attack a couple of years ago. An attacker could also compromise your build pipeline that happened to SolarWind, or an attacker could also try to compromise package manager account. This happened about just 2 weeks ago. Researchers showed that they could register expired domains and initiate reset password to take over package manager accounts. And last but not least, we see often attacks named typo squatting, where attackers registers common names or lookalike names in the hope of tricking users to install those dependencies instead of the genuine dependencies. Because of this, large attack surface, this is why the OpenSSF Scorecard project was created. In a nutshell, Scorecard is a tool that assesses a number of important security risks with a software development cycle for projects that are natively developed on GitHub. Scorecard can check whether you are following good practices. For example, are you using continuous testing, fuzzing, static analysis? This is an important signal because it reduces the chance of bugs, and it catches them early in the development cycle. Scorecard will also check whether you are updating your dependencies, or go also beyond that. It will check whether you have safe configuration settings on GitHub. One important setting is the so-called branch protection setting, which prevents code changes from by malicious developers. We have other checks, such as the webhook check, which will verify whether you have enabled authentication in your webhook configuration. Scorecard doesn't just look at good practices, it also warns about anti-patterns. For example, if you have a secret which is accessible to an untrusted pull request, Scorecard will warn you about that. Scorecard will also warn you about whether your CI runs are on GitHub, which are called GitHub workflows. It will warn you if they are overprivileged. And this is really important because an attacker could abuse those permissions, bypass code reviews, and change your code. Again, I'll show a demo of this later in the talk. There are two main use cases where we think Scorecard is beneficial. The first is to improve the security of your own project. And it can help you reduce the risk that your code will be tampered with by an attacker. Second, you can use Scorecard to assess the risk of your dependencies. For example, Scorecard can warn you if your dependencies appear to not be maintained. And that is a signal which tells you that the dependencies are likely not to receive security updates. So let's see some examples. And let's start with how you can use Scorecard to assess your dependencies. So this is pretty simple. All you have to do is run the CLI. In this example, we are running Scorecard against a repo called sum/repo-dependency. Scorecard will output some warnings about security risks. For example, the top warning indicates that the project exposes a secret to untrusted pull request. The second warning indicates that the project uses the default CI permission, which include the ability to push code directly to the repository, which is really dangerous. And this last warning indicates that the project does not declare its dependencies in an immutable way. So if the dependency is later compromised and becomes malicious, your project would automatically download this malicious dependency, and it could compromise the project or a binary that you've compiled. This happened recently with the npm caller package attack. If you are using Go in your project, the official pkg.go.dev website now integrates better with Scorecard. At the bottom right of the image, you see a link, and if you click on it, it takes you to a website called deps.dev, which shows you all the Scorecard results for a package. It gives you results for each of the check and also an aggregate score. In this case, it's 5.2 out of 10. All right, so now let's move on how you can use Scorecard in your project and install Scorecard as a GitHub action. So for this, I need to share a different tab, so bear with me. 1 second. All right. All right, so this is a project I created, Scorecard minus example. So what you do if you want to install Scorecard, you go to that security tab here. All right, and then you go to the left, code scanning alerts. I have already installed Scorecard on this repository, so some alerts are already populated, but ignore this for a second. I'll show you, we'll go through some of them in a second. If you want to install Scorecard the first time, on the top right corner here, you have a button, Add Scanning Tool. Click on it. And here you can search for Scorecard. And click Configure. So this automatically populates the workflow file for Scorecard to run. And all you have to do is push that to your repository. Scorecard runs daily, every day, and also on every push to the main branch. And as soon as Scorecard runs, you will get alerts populated in the scanning dashboard that I showed earlier. Something that I want to mention is that Scorecard takes a path token as an optional input. You don't have to declare one, but if you don't the branch protection check will be disabled. And this is due to a limitation of the current GitHub APIs. And we're working with GitHub to try to resolve this problem. So let's cancel the changes and look at some of the results. Scanning results. All right. So for example, if I click on the fuzzing check right here, you can see that Scorecard is complaining that the project is not fuzzed, which is correct. And there's other kind of checks, as you can see. Let's look at a critical result that Scorecard, a critical alert. So here in this alert, Scorecard is complaining and claiming that there is a script injection vulnerability in this file presubmit.yaml due to this variable. All right, so let's take a look at the file. So roughly speaking, what's happening here is that this workflow is run on every pull request, and it roughly does the following. It does a bunch of printing, so it looks pretty innocuous. But it turns out that this is actually a vulnerable workflow. And to understand why, you have to know that when GitHub runs this script right here, it basically substitutes the variable right here with the title of the pull request provided by a potential attacker. And this allows someone who sends a pull request to gain remote code execution. So don't take my word for it. Let's just demo it right now that we can actually get remote code execution. So as you can see, the last commit on this repo is here from 2 hours ago. It's called update test.txt. So let's create a pull request real quick. Let's call it hello. Create a pull request. All right, and let's change the title. Oops, this, 1 second. All right, I'm back. Okay, so let's create the pull request with this weird looking title. All this is really doing is it's escaping the double quote and then pulling some content and executing it. All right. If we look at the actions that are being, you can see that the pre-submit has kicked off. It's being run. There's no interaction from the maintainer. The job has completed. If we look at we can see that it claimed devsecConcrowd was here, which was the title, which is a word that was in the title of the pull request right here. And we can verify that there's a new commit that just happened, which is basically the remote code execution gave us access to push directly to the main branch of the repo. All right, so let's go back to the slides. All right, so that's the end of the demo. Let me real quickly say give you a few announcements. We have plenty of things coming up with the Scorecard project. We have badges coming up soon, a website. We are also improving the Scorecard action so that you can more easily view the results for your dependencies. And also, I'd like to give a shout out to this project, Allstar, which is an app from the OpenSSF, which helps you enforce policies at scale for Scorecard results. So thanks, everyone. That's the end of my talk. Just a plug, like the OpenSSF community is open, and if you're interested in joining the conversation and get involved, click the link on the slide. Thank you.
Wow, that was really eye-opening, Laurent. I had not seen that attack vector before through GitHub PRs and the titles of it like that. That is super interesting, and thank you for bringing that to everyone's attention there. Eric, did we have any questions for?
I think we just got one from Catherine. It says, would I be able to enable Scorecard in GitLab?
Yeah, so we're working on it. We don't have support for it yet. But yeah, it's in the pipeline. We have prioritized GitHub for now because they have more of the market share. But yeah, it's in the pipeline. And if anyone wants to help, like pull requests are welcome. In this case, probably a lot of pull requests.
Excellent. And again, shout out to OpenSSF for folks to check out and start contributing and be part of as well. Thank you so much, Laurent, and appreciate you being here.
Yeah, thanks for having me.
All right, see ya.
Bye, everyone.